zone, I'm going to give you some question on ozonolysis of alkene. Please do attempt, then we will move ahead. Writing. Can you solve it, Madiha and Aman? Aman, am I audible?
Yes, sir.
Can you solve it?
Okay, sir.
Okay. Please do solve it. I'm waiting. Please do let me know if you are unable to solve it. I will explain. On ozonolysis of an alkene, ethanol and propanol we need to write the IUPAC of alkene. We need to tell which alkene is used for ozonolysis, so that we will gain or we get ethanol or propanol. Let's see, I'm going to explain. Ethanol, write the structure of ethanol. You know that this is your ethanol, and propanol. You also know the structure of propanol. This is your propanol. Now, what I told you to do when this type of questions will be in your exam paper. So just write this in this way. Just write in this way. CH3, C double bond O, and this is your H. And again, this is C double bond O, and then H. And after this, you can see that this is CH2, and after that, CH3. What you need to do, just remove this O2 and make double bond between this carbon. There was H, and after this, there is a CH3, and after this, you can say this CH2, CH3. So this is the alkene from which, if you are going to do the generalization of alkene of this, you will get this aldehyde, and you can name it easily 1, 2, 3, 4, 5. So its name will be pent 2E. Is that clear, everyone? Aman, Madiha,
Yes, sir.
and Ring. Okay. Can I change the slide? Madiha. Thank you. Now let's just start the new topic, that is preparation of aldehyde. Especially this is preparation of aldehyde. In the previous we did the mixture of aldehyde and ketones, and here we started preparation of aldehydes. Now as you can see that this preparation of aldehyde is first from acyl chloride, or we can call it acid chloride. And this acid chloride or acyl chloride is also a carbonyl compound. Now I'm going to show you, if this is your benzene and if you have a functional group of acyl chloride, that means this. So you are going to use H2 in the presence of PD, BSO4, palladium, barium, sulfate. Then this will be reduced and hydrogen will be added to this point, Cl. So this will be, you can see C double bond O, and this is your H. So this becomes aldehyde now. So we can say either benzaldehyde. So this is how we can prepare this aldehyde from acyl chloride. It will be hydrogenated, that means hydrogen will be added at the place of chlorine. So in this way you can prepare aldehyde. Please do write. Let me know when you are done with this.
Done, sir.
Very good.
Done, sir.
Now you can see I'm gonna start the next preparation of aldehyde, that is from nitriles and esters. Nitriles, that means basically also known as cyanide. And there will be a name reaction which is very important. So from nitriles, basically I'm gonna write nitriles are reduced to corresponding nitriles are reduced to corresponding imine with stannous chloride. What is all this? I will explain it. First, let me write it. Write with me. With stannous chloride. This is your chloride. Butyl. With this is your stannous chloride. In the presence of hydrochloric acid. In the presence of hydrochloric acid, which on hydrolysis give corresponding aldehyde. Now, as you can see, this is your nitrites. So, if you are going to use SNCl, that is stannous chloride, in the presence of HCl, then it will be reduced to imine. Imine is RCH double bond NH, and after hydrolyzing this, that means H3O positive, H plus and OH minus, it will be converted into RCHO. I'm going to explain the mechanism, not the mechanism. I'm going to explain the reaction. You can see this is RC triple bond N. And in order to reduce it, you need to add hydrogen. What is reduction? Addition of hydrogen or removal of oxygen. So I'm going to break one of the bond between carbon and nitrogen and insert hydrogen to each carbon and nitrogen. And you can see that there will be RCH double bond NH. And this is basically known as imine. As you can see that this stannous chloride and HCl will help in reduction of nitriles and forms imine. After this, if you are going to do hydrolysis, that means H plus OH minus will be there. And you also know that there will be negative charge on nitrogen because it is more electronegative, and positive charge on carbon because it is more electropositive, less electronegative than nitrogen. So this negative will be attacking here and it will form RCHO, RC double bond. Please do write it. And this reaction is known as Stephen reaction. This reaction please do write it. Let me know when you are done with this. Are you done with this?
Yes, sir.
Very. So this is your Stephen reaction, and there is alternate method to prepare this aldehyde, and that is by using this what we call ester. So you can see alternate method. So there is nitrile, that is RCN. We are going to use wait, let me write a point about it and then I'll explain. So we can write nitriles are selectively reduced by diisobutyl aluminium. Right. Diisobutyl aluminum hydride that we are going to denote or symbolize with double H. To imines, first it will be reduced to imines, followed by hydrolysis to aldehydes. So this is another method to prepare aldehyde. As you can see the reaction, we are going to use RCN, this is nitriles, and if you are going to use Al, that is aluminum, and this is isobutyl, and it is twice. So double H it is, and then followed by hydrolysis, you will directly get RCHO, that is hydrogen. So I'm going to give you a reaction from NCRT, that is CH3CH double bond CH, single bond CH2 and if you are going to use first double H, that is same that I have written here, and followed by hydrolysis, what will be the product? Please write the IUPAC of the product. Please do let me know when you are done with this.
Yes, sir. Done.
What is the name of the product? See, what you need to do, just replace this with CHO and you will get it. The rest part will be as it is, CH3, CS, and then CH2, and then CH2. After that, this will be CH. With introduction of diable H, there will be intermediate product that is basically your imine. And what is imine? The rest part will be as it is, and imine will be basically, you can see that CN has triple bond, so one of the bond will be broken and there will be CH double bond NH. This is your imine. After this you are going to do hydrolysis, then you will get aldehyde, as you can read this straight. Okay. Aman, Rim, and Madhya, please do respond. So what will be the name of the product? It's very easy to understand. 1, 2, 3, 4, 5, 6. No branch, so 6 hex, nature of bond, double bond, so 2 in, and then 1 out. Is that clear to everyone? Everyone done with this?
Yes, sir.
Very good. Now we are going to prepare aldehyde from esters. So I can write esters are also reduced esters are also reduced to aldehydes with diable H. This diable H is a reducing agent. It can reduce. So I'm going to write it here. As if you have this CH3, CH2, CH2, and then C double bond O, and then this is O, and this is CH3. And if you are going to use diable H first, and then hydrolyze H2, what will happen? This will be broken and hydrogen will be added with this. So it will be directly converted into aldehyde CH2, and then C double bond O. This will be converted into aldehyde. So this is how ester can be converted into aldehyde. So I'm gonna give you a question like this. Can you tell me the name of the product? Everyone done with this? Rim, are you there? Rim, am I audible?
Yes, sir.
Have you done? Are you done with this?
No, sir.
See, what you need to do, just break this bond that goes. So you will get a product like this. And this will be your measure product. Now I'm going to name it 1, 2, 3, 4. This is your branch. So it will be 2-methyl and then one butane and one isobutane. Is that clear?
Yes, sir.
Can I change the slide?
Yes, sir.
Now see, we are going to prepare aldehydes from hydrocarbons. Nadia, are you there? Have you completed the previous question?
Yes, sir.
You are not. No.
No, I actually got disconnected because of the internet connection.
Okay. This was the question before. Take a screenshot.
Done, sir.
Thank you. Now you can see here that from hydrocarbon we are going to prepare aldehyde, and in this we have the first method by oxidation of methyl benzene. By oxidation of methyl benzene. So as you can see, this is by oxidation of methyl benzene. We have the use of chromyl chloride. Use of chromyl chloride. And chromyl chloride has a formula CrO2Cl. This reaction is very important. Please do write it up to this. I'm going to write the reaction. It has been asked so many times. So basically here, if you have methyl benzene, as you know, this is your methyl benzene. Wait a minute. So this is your methyl benzene. And if you are going to use, am I audible clearly? Am I audible clearly?
Yes, sir.
If you are going to use this chromyl chloride in the presence of carbon disulfide, then you will get an intermediate. And this intermediate is basically your complex compound. Chromium complex it is basically. So I'm gonna show you this. It is again. So this will be your chromium complex CH and bracket OCr. This is not Z, this is R, then O, then H, and then Cl2 whole plus. This is known as chromium complex. And if you are going to hydrolyze this chromium complex as 3O positive, then you will get benzaldehyde. then you will get benzaldehyde. This is what you will get, CHO benzaldehyde. So this is how we prepare aldehyde from hydrocarbon by oxidation of methyl benzene. This is methyl benzene and you can see it is oxidizes. That means oxygen is added into this. Okay. So please do write it. This is the first method. And this reaction is known as Aldehyde reaction. This reaction is known as Aldehyde reaction. Please do write. Madhya, when will be your final, not final exams, pre-boards?
Sir, my pre-boards are in January 2nd week, and from Sunday I have unit test.
So that we will be complete our syllabus. How's your preparation going?
Yes, sir, it's going. I have chemistry exam on Sunday.
Very good. Are you done with this? Madhya, are you done with this?
Sir, just 1 minute.
Oh, take your time. No problem.
Done, sir.
Very good. Now see the B part of this, use of chromic oxide. So in the B part, we are going to use of chromic oxide. And chromic oxide is basically CRO. So we are going to use this on methyl benzene. So as you can see, this is your methyl benzene that I'm going to draw. This is your methyl benzene. And if you are going to use chromic oxide, so this will be used in the presence of peroxide or anhydride, we can call it CH3CO whole twice O, that is anhydride, acid anhydride at the temperature cold, or you can say 0 to 10 degrees centigrade. Then you will get a complex in the same way that you got in the previous one. But here the complex will be CH and then OCO, CH3 whole twice. After this, again hydrolysis will take place and heat, then you will get benzaldehyde. Then you will get benzaldehyde. So these reactions are very important. Please do write it. Please do let me know when you are done. Now the second method from hydrocarbon is your by side chain chlorinase. By side chain chlorinase followed by hydrolysis. Hydrolysis. So I'm gonna again use this methyl benzene and do side chlorinase. So chlorinase, that means addition of chlorine. So how we are going to do this? Cl2 in the presence of sunlight, H nu. As you know that this can go to this hydrogen. It will replace hydrogen. So as you can, this is your methyl benzene. Now it is CHCl. Two hydrogen is replaced by 2 chlorine, and if you are going to pass it through H2 at 373 Kelvin, that means high temperature, 100 degrees centigrade, it will be directly converted into this carboxylic acid. Sorry, not carboxylic, aldehyde. It will be directly converted into aldehyde. Benzaldehyde again. So this will be your benzaldehyde. Benzaldehyde is common name as well as IUPAC name. Now we treated it as IUPAC. It's initially what we call its common name. IUPAC name was benzene carbaldehyde, and its common name was benzaldehyde. Now it was also treated as IUPAC as well as common. Please do write it. Are you done with this?
1 minute, sir.
Okay. Let me check.
Done, sir.
Very good. Now the next, which is very important, that is called Gatterman post-selection. So by Gatterman post-selection, and it's very easy. You are going to use benzene. This is your benzene, and if you are going to use carbon monoxide in the presence of HCl in anhydride AlCl3, or either you can use CuCl, then it will be directly converted into benzene. This is a name reaction which is very important. So, is that clear?
Yes, sir.
So I'm going to give some questions up to this point. Please send it in PDF like you did on 14th November. IUPAC is easy and it's very important. That's why I always pick one question on this, give on to one question from this. Write the IUPAC of all. Today I'm not going to give more questions on IUPAC. And this is your this is bracket. This is bracket. Are you writing the question with me?
Yes, sir.
P comma P dash dihydroxy benzo phenol. Please do let me know when you are done up to this.
Sir, I'm not able to see your screen.
What you just said, which part?
No, sir, your screen is not visible.
My screen is not visible.
No, sir.
Is your connection weak or strong? Can you see the screen?
Sir, I'll rejoin.
Okay. Can you see the screen?
Yes, I can see now.
Wait a minute. You cannot see the screen. Can you see the screen now?
Yes, sir, I can see.
Okay. How many questions you have written till?
I'm writing the third part of the second one.
Please do solve it and make a PDF and send it to the group. I will be back in a minute. Okay.
Okay, sir.
Let me know when you are done with this, Nadia.
Okay, sir. Sir, I'm done.